Okay, so welcome back, and now we're going to go back and we're going to discuss something that came up before, and this is about Koch's Snowflake. Okay, so now we're going to define a sequence of figures. Okay, so we're going to call this a sequence of f of n, where f sub n represents a figure. Okay, so f0 is just going to be an equilateral triangle with sides of length 1 unit. Okay, given here. And then here's an example of f1. So what we're going to do is, for all subsequent figures, for n equal to 1 or higher, what we're going to do is f of n is going to be defined recursively. And it's going to be defined as such. We're going to say f of n is going to be the figure created by removing the middle third of each side of the previous figure. So in other words, for example, going from f0 to f1, we removed, again, my artistic skill notwithstanding, we remove 1/3, the middle third of each side, and we replace it with another equilateral triangle that is pointing outward. Okay, and incidentally, the length of each one of those sides of the equilateral triangle that we end up creating is going to have a length of 1/3 of the length of the previous side. Again, that's incidental. I don't know if we're going to use that or not, but I don't think so. So here's the thing. So we're going to replace it with an equilateral triangle on each side, facing outward, pointing outward, and that's going to be the definition, or how we're going to create f of n. Okay, so that's defined recursively. And then what happens is, as n goes to infinity, the limiting figure becomes what's known as Koch's snowflake. So here's the thing that we're going to do in the next video or so, is we're going to look at finding the perimeter around f of n, right? So we're going to see if we can find a way of representing the perimeter of f of n, right, for all n greater than or equal to 1, and then use that to find the perimeter of Koch's snowflake by taking the limit of that as n approaches infinity. And then what we're going to do is we're going to do a similar approach to finding the area. So we're going to find the area, a sub n, of each of the figures, right? And then we're going to take the limit of that to see if we can find the area of Koch's snowflake. Okay, so that's what we're going to do next. Have a great day.